All right, hello everybody. So I am Paul. I'm a senior data scientist with HEB. Uh, Before that, I was actually nearby at Caltech doing acoustics research. Ended up pulling the cord to leave grad school early, but still like to come by and see some people. I will say, towards the final year of my grad school, I was kind of looking at ways to build my skills, make myself more ready for industry. And I had this grand idea of like, hey, we all have this code that we're working together in the lab. We're emailing files to each other. This is a horrible idea. Let's establish a Git repo. And I set it up and nobody else used it. But thanks to the magic that you guys are all attending my tutorial, we're going to start building a code base for an experimental lab together. So, if you would like to navigate to GitHub, Anzel PWJ, Git PDLA 2019, we're going to have a few exercises where I'm going to interact with some of you. Who here has Git set up on their computer, would be willing to be a guinea pig, and is able to connect to the Wi-Fi? Do we have any takers? Hand these out. All right. Overview of what we're going to be going on. Largely the work is collaborating with others. So merge conflicts, creating code branches, code review, pull requests, opening issues. Depending on time, we can also do some recovering from errors. I guess quick raise of hands from the audience here. Who here is a beginner to Git? Okay, we've got a few. I'm not going to go too much really into the beginning from there. I will recommend, if you'd like a good tutorial, Software Carpentry has some excellent online material. And all their material is largely Git by yourself. So this lecture is going to be kind of an extension of the lectures that Software Carpentry has. As far as more advanced topics that we're going to be not really going to be going over, rebasing, briefly touch on that, but it's kind of a harder topic to get through. Git hooks, Git tags, fairly straightforward, especially Git tags, but less relevant. The .git ignore file is fantastically useful and not so relevant for our time here. I left my sticky notes at home. I am going to ask you to start with the exercises in just 1 second. So, for those here, who here has run into a merge conflict? Who here hates running into a merge conflict? They are absolutely no fun. So let me show you the code base that we've got here. We are building out some code for our acoustics lab. And right now we're starting with, just got this folder here, instruments. We have some calibrations, so we have some force sensors, and they'll give us a force voltage result. We also have a bit of code that will take these calibrations and give us a nice little plot here. So if I want to do Python force sensors code, and I give it one of our force sensors like this, beautiful plot. Our goal, as we work through this, is we want to extend this to the microphones code that we have. We want to be able to plot some transfer functions for these, which is kind of a similar thing of just how live the microphone is for different frequencies. And we want to have some basic tests for this code, because testing is a lovely thing and would have saved me much time many years ago. As a start of testing, let's add a dummy force sensor here. So we'd like to have kind of a fake force sensor. It's a little hard for me to predict between these forces voltages what's going to be a force for, if I have 15 newtons, what's the voltage going to be exactly? Something around 1.1 or something. I can't tell. So we're going to add a dummy sensor here and use that to generate something. So, sir, do you have number 1 on 6? Who's number 1? Okay, the fellow in the back. So, exercises. So we are going to add, you are taking it upon yourself to add this little bit of code to the repo. And because this is a private repository, I am going to need to add you as a collaborator. All right, so what's your GitHub username? Sorry? All right, so you should be getting an email.
So is it fair to say step 1 is to make the connection between your collaborators with, so you sent him in a perfect world, what would really happen here?
So in a perfect world, if you're part of an organization, they will generally add you as part of the Git repository, and that will be handled for you. The other alternative is generally, if you're working with an open source project, you'll generally have to be interacting with them a lot to be added as a collaborator. But what you'll do if you feel like you need to make changes to something is you'll create a fork, and we'll go over that a little bit later in the session. You'll make the changes in your fork, which is your own personal version of that repository, and then you'll move the changes from your personal fork back to the main branch. So we'll get to that.
So in our situation here, we got stuck with the email, right?
Yeah,
Okay.
so I just checked my email, including my spam, and I haven't received it. I just tried editing it online, just in the GitHub editor.
Yeah, and then it makes you generate your own fork.
Yeah, it's gonna make me fork it, and
I'll put this on my own end, but much appreciate for you trying and taking this.
Yeah.
So I will make this on my own end. So this. So I've added this fake sensor here. And I've done this on GitHub. My computer doesn't actually know about the change that I've made. And even though theoretically I'm editing the code, both if I'm doing it in Visual Studio or I'm doing it on GitHub, these are two different computers that are going to have two different views of what's going on. If I go to my terminal, log, I don't know about this change I've made on GitHub. If I was smart, every time I was going to make changes, I would do git fetch. Let me move this up so people can see. If I was smart, I would do git fetch origin master and download the latest changes. I can tell you I forget that a lot of times. Other people forget that a lot of times. And if you were working at the same time as somebody else, you might not even know about these changes coming through. I will say, this is one reason I'm a very big proponent of using a Git graphical interface like SourceTree. SourceTree or VS Code or something, they can be set to automatically, like every few minutes, look at Git, look at GitHub, look at Bitbucket, whatever, and see, is there anything new for me to download? So SourceTree is telling me, hey, you have something you need to pull. But we're going to cause a merge conflict. So I'm copying this code over here. But I'm doing a completely other version of this. I'm going to 2, 4, 6, 8. 4, 6, 8, 10. I save this. Wrong icon. My turn. I add and commit. Everything looks fine until I try and push. That's for the password. And then we get the error message we all know and love. Okay. Git pull. Automatic merge conflict. Thankfully, VS Code, Atom, both of these will actually give you a nice highlight of the things that fixed. And this is a relatively easy thing to see. I can see 2 versions of the same thing. I'll know what to pick. Life is easy when it's, you're just picking a couple lines, or you're having to just kind of concatenate one set of code with another set of code. What's really hard is having this kind of pop up unexpected every time you're adding code, and B, if you're making much bigger changes, trying to track down everywhere where things are going to fail. Merge conflicts are drama. The real goal that you want to have is let's keep them controlled, and let's anticipate what needs to happen. Ultimately there's not going to be any substitute for communicating with other people that if you're working with them on a basis of code. But by using branches and forks, it's a lot easier to know, like, oh, I anticipate we're going to see a conflict here. Let me talk with this other person. Or, at least I can work on my code, and at the very end, I can resolve all the merge conflicts. So, who here has used branches before? Show of hands. So, about maybe a quarter of the room. The basic way you can sort of think about branches are they're alternate versions of the code. I'll create a branch, and I can edit the code all I want in that branch. But as soon as anybody else working on the master branch or anything else, they're not going to see the changes that I am making this branch. So this makes it very easy for me to do my work. Somebody else can do their other work. And then once I'm satisfied with the changes I've made with my branch, then you'll merge the branches. You'll take the code changes you've made in your branch and put it back into master or dev or whatever is kind of the main working draft you have. And that's how you add code to the main thing. So if you're working alone, this is kind of the process you're doing. You're on master, you have your commits, and you just have one commit after another after another. The basic cycle you're going to do with branches is, instead of adding all your changes to master, you open a branch, you make your changes there, you merge them back to master. Why go through all this rigmarole? Well, somebody else is doing the same thing around the same time. And, this thing, any changes that are getting made here, this guy doesn't need to know or worry about it. And then when we make this merge down here, it's going to be much more controlled. And generally GitHub, Bitbucket, GitLab, they will warn us ahead of time, hey, there's going to be merge conflicts. And so you can anticipate what's going to happen. And you can make you can sort of save dealing with the merge conflict for last. So why are we branching? We're working with others without stepping on toes. If you have this idea of like, oh, I want to just change things up, I have this experiment I want to do, great, you create a branch, play around with the code as much as you want. It's not going to affect anything else. But the most important thing is this whole process of branching is what really enables code review. When you try and merge the code in, you'll open what's called a pull request, and we'll get to that in just a second. And that's going to be a step where people are going to look at the changes you've made and critique them. I am a very firm believer in code review. There was research by Emmy Fagan, 1976. Hour for hour, code review is the most effective use of time. There's some caveats. We'll get to that in a little bit. If you're working in an industry, the earlier you catch bugs, the cheaper it is. And this is some research that SmartBear did. It is by a factor of 10 sometimes how much cheaper it is to catch bugs earlier in the process. If you're working in academia, replace cost with time and frustration spent. Catching these things early makes everybody's life much easier. It's also a great way, you're collaborating with other people understand the code that you're writing. It's an opportunity for you to improve your skills and help other people improve their skills. 100% I'm a firm believer in the use of code review. So the basic cycle that we're going to do is we will create a branch, go through the Git things we have. We're going to open a pull request, and we're going to ask people, hey, these are the changes I've made. They might say, looks good, ready to go. In that case, you can merge it. More often, they'll say, hey, can you fix X, Y, and Z? And you'll address these things. If there's any merge conflicts, you'll resolve them, and then things will resolve. Okay, how do we actually do this? Git, as of 2.23, decided, hey, let's not use checkout for 4 different unrelated concepts. It's amazing. They could have learned from Mercurial years ago. Do you think all the computers you're going to use have upgraded to Git 2.23? No, unfortunately. So if you are using 2.23, the way you kind of switch around branches is helpfully named Git switch. Otherwise, Git checkout is kind of the universal way of creating a branch. Let me actually open the terminal. So, Git branch, you can see what branches we have. Git switch -c, new branch. There we go. Switch. See, new branch. And so you can see we're on this new branch thing here. If I need to switch back to master, if I need to delete this branch, either you'll have the small d, I'll let you do that. If it complains, you can do big D, and that will fully delete everything. If you need to load a branch from your remote repository, so if we look at GitHub here, go back. We can actually see I have 3 other branches here. So we have this exercises dummy mic branch. We have force sensors unit test. Again, my computer doesn't know about these. So I would have to tell it git fetch origin exercises mic. And that's how I tell myself, no, computer, there's another branch. Again, source tree, VS Code or whatnot, these tools can do this for you, which is very helpful. Sorry? Yeah, I'm having to enter them in. Either there is I believe there is a fetch option. I want to say it's -T, and I'm probably wrong. But there's a way to basically tell your computer, look at the remote server and tell me all the branches that are available. Alternately, if I go to source tree, here. So this GUI is going to tell me, hey, we've got these 3 exercise branches here. And I apologize, I don't know how to increase the size of the text here, but a good GUI program will actually tell you all the remote branches there. And if I wanted to download the branch to my computer, I could just double click on it, and it will tell me, hey, you want to check out this branch and create a local branch based on it? So that's generally going to be the best way to go about doing this. Talked about deleting branches. Naming branches, kind of like naming variables. It's good to be informative. So new branch is not a good name. New piezo calibrations is great. One trick you can do with creating branches is you can have kind of this, you can pretend like you're creating folders. So you do something / something else. If you actually look at what we have in source tree, I have 3 branches that are named exercises / something. It is basically saying like, oh, you want to create a folder like this. And so, it's just a /, it's just a string, a character in our string. But certain GUI clients will tell you like, hey, this is a good way to, obviously you want to kind of collate all these things together. And even if you just have a lot of branches and you're just looking through them alphabetically, that's another good way to be able to sort like, here are all the branches that deal with, this Nature paper we're writing because we're publishing to Nature or something. If you work with a ticket system, so if you're using Trello or Jira or something like that, I also really like to include the ticket name as a part of the branch. That's a very helpful way to be able to, if somebody's like, what's going on with this branch? Why are you doing this? They can say, oh, well, this deals with ticket 165. They'll go to Trello and they'll say, okay, this is the context I need to know for the branch we've created. So, as an example of kind of this, there's a few different ways I use branches. The most basic thing I use is 1 branch per ticket. So, this is I'm adding a unit test for this code function. I have a ticket for that. Here's my branch for it. I do it. It's done. if you have a really big project that's going to involve a lot of work, I'll create a branch for that big project, and then I'll create little branches off of that branch. And that will let, then I can do like lots of code reviews and whatnot for the little branches. And once all my work for that big project is done, then I can merge that whole thing back in. And that's a good way to kind of cut up the work and let people go through things step by step. So that's a good thing to do. I mentioned one-off tests. Another thing that you'll hear people doing, if you're in a software context where you create releases of code. So let's say you have some like really important code that is all the back end for a big web service or something. What people might do there is they'll say, okay, every week we're going to cut a release branch, and the release branch is what goes onto our servers. And so we have a very clear idea of like, this is the code that's running this week. And next week, Tuesday, we're going to cut a new release branch and deploy it. If you need to make small hot fixes to that, you can. But that way, you don't have kind of a working draft of code for really important fundamental code that everyone is using. You have like, this is a set, this is our release branch. This is what's going on the servers. You might also have cases where, if you're doing a really big important thing, you'll have people doing quality assurance on it. So you'll have the dev branch, which is kind of your working copy, and then every so often the QA folks will take the stuff from the dev branch to the master branch, and they'll test everything there and make sure nothing breaks. And then from there, they'll cut things to the release branch. So you can get pretty complicated branch structures depending on your needs. My advice there is just use as much structure as is reasonable. Small branches back to master. If you're only working with a few other people, that's fine. Thank you very much. But if you're working on something where if this goes down, the hospital system is going to crash or whatnot, you're going to want to have a lot more structure in place to make sure things do not break. But very good question, thank you. And I should briefly interrupt. Does anybody else have any questions on what we've covered so far?
If I'm working in a branch and waiting on a code review, I need to sort of stop working on that branch. Mm-hmm. Then I want to continue some work that builds off that further. Do you branch off the branch? And is there trouble bringing that back together? Or kind of where should I do that continued work while I wait on a code review?
You can branch off the branch. And then so you have the branch that's undergoing code review, you're fixing things, and as you're fixing things in that branch, you can merge the changes from the branch under code review to the new branch you have and just grab all the changes that are getting made there. So a little bit ago. It's the wrong thing. Terminal. We ran a little line of code to plot things. Nowhere is it documented how we do this. So I will go through the process now of creating a branch. Git check out the old term. Add instructions to calibrations. So we're in the new branch. As we can see here. So I will edit my code. Say to test. Run. Python parse sensors code.py sensor ID. Do the same for the microphone. captions. So I've made my changes. Git add. Git commit. Add more dots. And the only difference that I'm making here is instead of git push origin master, which you typically do, I do git push origin name of the branch. Asks for my password. It'll tell me new branch has been created. We can go over to GitHub. And we can see, if I refresh the page, the new branch. And very helpfully, GitHub, GitLab, Bitbucket, they all generally have an idea of like, hey, you pushed a new branch to me. You probably want to open a pull request, which we will get to in a little bit. So if we were going to edit this code together, I would click this button. But we are going to try another exercise. So who has the page labeled number 2? Okay. Let me see if I can... Let me try and add you as a collaborator, and you'll see if this works. So what's your GitHub username? EYOUNGS?
Yep.
Great. So you should be hopefully you should be getting an email, and the email will have a button for you to click.
Yeah, I'm also not seeing the email.
Okay. Then we'll move forward. Sorry? No, unfortunately. So, experiment. I thought this might work. I have created a branch for this, so we can pretend that you've added this code. It is here in exercise microphone code. So if we look at the commits this has, wrong one, dummy mic. We'll see we have the code for this. I mentioned forks a little bit ago. Basically, a branch is an alternate version of the code that lives in the same repo. A fork is a version of the code that lives in a different repo. So most commonly, you're going to be forking the code to your own account, and you can say like, so this is a branch plus. Generally, as I said, if you work with big open source projects, they don't want, it's to create branches, as you can see, you need to be added as a collaborator, which is not so intuitive. And B, they don't want people just kind of cluttering, putting all sorts of nonsense in the branches. So what you'll do instead, if you want to create a fork, is you can click this fork button up here. It will copy the branch to your personal, to your account. You can branch, you can make all the changes you want there, and you can merge changes you make in your personal fork back to the main version of code. So, if I wanted to work on matplotlib, here, I'm going to go up, I'm going to say I'm not going to have the permission to create a branch here, but I can create a fork. I'm going to fork it to my account. This will create a copy. And then I can make all the changes that I want in this fork. And if I had an idea of how to improve matplotlib or something else, I'd do the work here, and then I would merge the changes from the fork in this repository back to the main matplotlib repository. Another common case where you might be using forks is, let's say you have a tutorial here at PyData or somewhere else that you really like. So I was listening to Daniel Brooks' PyTorch tutorial. I want to take his code and I want to make lots of changes with it as I mess around with things. But I don't want to screw up his version of the code. I can fork his changes to my repository. And then I can play around with his tutorial material as much as I want, and it's not going to affect the work that Daniel has done. The one thing that gets a little tricky with forks is you need to tell Git about both the original repository, so matplotlib, and your personal version of your repository. So if big changes happen in the big repository, you can download those as opposed to downloading it from your personal version. The term to search for is called git set upstream. So let me go through these things. So you're making your changes. You're like, okay, this looks good. I want somebody to review it, and I want them to say, great, let's add this to the code. Pull requests and merge requests are two terms for the same thing. GitLab uses merge requests. It's a more accurate term. GitHub has about 50% market share, so everybody calls them pull requests. Same thing, though. You're taking your code that you've done, and you're bringing it back to the original master or whatever other branch you want to combine it with. So I added this as instructions to calibrations. I can either click on this pull requests tab up here, or it's helpfully saying, hey, you want to create a pull request. And as I create a pull request, I'm going to say, I'm going to give it a helpful title, add some comments to calibrations. So this will help people to test their work. For reviewers, tag somebody else as to look over your pull request. Assignees is going to be like, this is the person whose job it is to kind of massage everything through this. So once I've added a helpful title and a helpful description of what's going on, Git will say like, hey, can I merge? Can I not merge? In this case, I have no merge conflicts, so this would be ready to merge. And then anybody else looking at this, they can look at the commits. So they can see the changes I've made. I've made one commit. They can also look at it per file, all the changes that have been made. And as you're looking at these things, for example, you can add comments. So I can either go to the files change or specific commits, and I can click on these buttons here, and I can say the $sign. That's weird. Add a simple comment. You can also just add various comments here. And so this is the main mechanism that you're generally going to be using to do code review with other people. Yes?
This has been suggested to me by software developers in my company as well. But in more of a data science role where we're taking on a variety of projects and often we're starting new repositories from scratch or pretty much from scratch. Have you seen ways of adapting this kind of pull request, merge request workflow to fresh repositories as opposed to updates to existing ones?
So I think there's a few answers I'll have there. First thing is, if you're building a repository, you create a new repository. It's just a new folder of work. You do your changes there. And repositories can come and go as work is done. So you can have like a very small project. You have a repository for it, and you say, okay, project's over. That wasn't very interesting, and you can abandon it. A particular issue with data science work is Jupyter Notebooks. Jupyter Notebook does not play very nicely with version control right out of the box. And there's not a super great reason for it not to do so. Besides, well, the tooling does exist. So there's yeah, you can do that. I've actually grown less and less. I like to view notebooks as like kind of a final output versus like where I like to do a lot of my active development, but that's a personal style. There is a tool called Review NB that you can see actually has these two panes that show you the differences that are getting made. It's a paid product, although if you are working in open source products, they will offer a free license for that. But if you're in a company, you will have to pay. I don't know what their policy is, say, for educational or government research institutions. That would be something to look into. But this would be actually a very helpful tool if you're doing this. The other thing that you're going to be dealing with if you're dealing with a lot of data analysis is Excel. Let me introduce you to Excel Trail. A similar paid product. Again, there isn't a great reason that Excel doesn't natively handle code diffs, because Excel are basically XML trees. There are tools to diff trees, there are algorithms to diff trees. They just haven't really implemented it yet in Excel to do this. But if you're working in a context where a lot of people are using Excel, which is most commercial enterprises, something like this will actually point out, in cell K51, people have made these changes here. Another common issue you might have if you're doing code work is, you have like some common code that you would like to have between different repositories, but you have different projects from there. What I might say would work then is you might want to put the common code into like a Python package, and then like the common code can be its own repository, and then the other repositories can just download that package and use. So, common instance that I've had is you've written code that like, this is my code that loads data from our FTP server. This is my code that loads stuff from MySQL. This is my code that loads stuff from Postgres. This is my code that loads stuff off of Dropbox. You just have a bunch of helper functions in Python. That bit of code can be put into a package, and then every other repository, you can download that, you can install that package, and then you have all the connectors. So that would be an approach I would take. So I've made my changes. I'm very happy with my own work. Don't be happy with your own work. it the long and short of it is it's very easy to fool yourself. It's if you are going to do code review, like you make your changes, you step away, you do something else for a while, and then you go back and you review your code then, because that having a fresh set of eyes is good will be very helpful to kind of say like, oh, I made a mistake there, and then you can catch that. And then, more important, having somebody else look at what you've done. They don't have the same context. But I'm going to confirm this merge. And our changes are reflected here. So, who should review your code request? How many of you are familiar with Git blame? Small smattering of people. You can tell the emotional state of whoever wrote that command. The Git annotate does the same thing. You're not going to remember Git annotate. You will remember Git blame. Git blame basically tells you. Look at requirements.txt. Git blame will tell you the last time every line was changed in your code. So you can see I'm the only person who's worked on this. It's 3 lines. It'll tell you the time of the commit. It will also give you part of the commit hash. So if you need to actually look for it in Git log, you can find when this was done. But if I'm working on a file and I want to say like, okay, who do I need to tag as reviewers for this? The first thing I will do is I'll run git blame on the file, and I will see, oh, so and so worked on this. They should probably be reviewers on this code. I don't know if GitHub does this automatically. I know Bitbucket will actually run git blame on the file, and they'll suggest reviewers based on the git blame. They'll say, hey, I see these people have run on this. Maybe you should tag them. The other approach is creating what's called a code owners file. This is not in base Git, but GitHub, GitLab, Bitbucket. There's a special file you can create. It looks like a README or something. But you can tell it like every file that is in this folder, this is the person who should review this. Every file that ends in .py, this guy is our Python expert, or this guy is our R expert, so they should review Python or R files. So, for our exercise, we're having a little bit of difficulty getting people to join. So if I was going to pull requests, so if I don't have a pull request I can see, I will go to this pull request tab here, new pull request, master, compare master. That's, master. There's no difference between master. But I want to add our dummy microphone. So we'll say able to merge. We can see it will show me the changes that are being made. We can click create pull request. I can add reviewers if there was anybody with this. But since we don't have anybody for this, I'll create that. And again, Git will tell us if there's merge conflicts or not. No merge conflicts, confirm the merge. And so now looking back at the master branch, we'll see commits for the pull requests that we've created, and we'll see the commits I've done as well. So all this code is now in the master branch. Is the code on my computer? No. What's the command I would run to pull the code back onto my computer? Not merge. How do I tell my computer that there's remote changes? Exactly, git fetch. So I'll make sure I'm on the correct branch. Git switch master. If I just tried git pull origin master, oh, that changed. Sometimes it works. Yeah, I've had inconsistent results with fetch, but it's a good habit to have, especially if you need to grab any new branch, and yeah, sometimes things just disappear periodically. I think I know why it worked. Source tree was automatically fetching for me in the background, so thanks, source tree. How do we make a good pull request? There's a really good book I recommend everybody read. It's edited by Greg Wilson and Andy Aram. It's called Making Software. Basically, meta-analyses of different aspects of industrial code review. So, what research do we actually have in what works with doing code review? What works with, what research do we have on quality metrics between closed and open source things? Fantastic book. These next few slides are from their chapter on code review. I mentioned before, M.E. Fagan said the most productive use of time for code review, the most productive use of time is code review. Cohen in 2006 said the most productive use of time is the first hour of code review. You're fresh for an hour. After an hour, you get tired, you're not finding errors, you need to take a break. Consequently, if somebody else needs to review, if your pull request is really big and somebody else needs to look at your code for multiple hours, they're either going to have to do it over a series of time, or they're not going to be able to be very thorough. So 1 hour of time, in terms of lines of code, that tracks to about a few hundred lines. I'm not actually aware if there's if there's a real language dependency on this. The fact being, you do a lot more with 20 lines of Python than you do with 20 lines of Java or C. But one way or another, you need to have relatively small digestible bites for people to do. In really big open source projects, people will reject pull requests that are too big because they'll say, this is too much for us to be able to understand all the ramifications of what's happening. In terms of actually doing code review, so how many of you have had meetings for code review? 2, 3, 4, 5, 6. 6 people. Meetings are good for one thing only, and that's if you have a bug that's really hard to figure out. Most of the time, just reading the code and running it on your own, you're able to catch 95% plus of the bugs. You only need to call a meeting when something's really subtle and you're not quite sure what's going on. If you are opening code reviews, it is perfectly fine to have an incomplete code change. Open up the code review, just mark it as work in progress or WIP, and just let people know, like, this isn't ready yet, but I'd like you to look this over. as I say, 3 hours of work that you have to completely redo is a lot better than 10 hours of work that you have to completely redo. Being able to collaborate with people early, especially if it's kind of a bigger project, is going to save you a lot of difficulty and a lot of headache when you find out, like, oh, this is not remotely what we needed. Commits as checkpoints. How many people have seen commit histories that look like this? I've had a couple coworkers that would do that, and it's like, no, you don't have to do every tiny change. It works. There's a technique called squashing, where you use Git rebase to basically combine sets of PRs together, but trying to kind of trying to keep the number of commits to a reasonable level is very helpful, because if you have kind of a bigger project, one thing I may try doing is I'll look commit by commit to see all the changes that were made. I mentioned earlier, if you have a really big code change that you need to make, try and do it as a series of smaller commits before everything goes back to the main commit. At least in this case, all these smaller pull requests that you do, it's going to let people be more confident that, okay, in the end of this has been 4,000 lines of code, but we've more methodically gone through this, and we're reasonably confident that everything is correct, and so we can push this back to master. Just trying to do a massive commit to master. I've had coworkers that have tried to commit something like 10K lines of code right before they're about to leave the company. It's very endearing. It's also very helpful because, oh hey, I need to meet with you to debrief because I'm taking over your project. Oh, you're very busy with your giant code merge that you didn't merge anything for the past 6 months. Thanks. Guess I'm not debriefing with you. Reviewing somebody else's code. There's a really good talk by Nina Jurenko. The title is Pythonic Code Reviews. This bit.ly Py Code Reviews will take you there that way. The long and short of it, if you're reviewing somebody else's code, is don't be a jerk. Specifically, what does that mean? Code reviews are an opportunity for people to practice, to improve their craft. It's not where you should be talking about how much better of a reviewer you are. It's not an occasion for you to, you need to pick and choose your battles of what to nitpick, versus, fix this class of problems. And, be supportive. It's very nice if somebody did something really good to say, like, hey, this looks great, good job. Use decorators. I learned something new that way. The other thing I will always suggest, if possible, if you're reviewing somebody else's code, fetch that code, bring it to your computer, and run it. The number of PRs I've been able to find defects because somebody made a change and they didn't test that their code worked. Or their code works on their computer, but they have a bunch of Python packages that they forgot to add to requirements.txt. And I'm not going to say I'm particularly great. I've also made that same mistake of how hard, I don't need to test this. It's just such a small change. And then I forget a comma and the code doesn't work. But, going through the exercise of, all right, download this code, run the test. Does it work? Does it fail? That is a really important way to be able to say, like, this is good code, check, or no, we found a bug. The one exception I've had, and in particular in my current company I've had a real trouble with, is sometimes for really big data projects that live in the cloud. So You're dealing with you're building a workflow. It processes, a terabyte of data. Spark is chugging along. You might, instead of showing like, hey, this runs on my computer, you'll have to show like, hey, here's a demonstration of it running on the target computer. Maybe instead of, say, for data workflows, you might output to a temporary database schema rather than like the production database schemas. But one way or another, either running on your machine or running on the target machine, but to kind of a development database. These are ways to show like, no, this code works. So we are going to do a code review together. So I have base master compare microphone code. So we have force sensors code that plots the force response curve. We saw that early on. We want to add the same for the microphone code. This is a much larger bit of code than adding just a few lines here. So I create a title. I give a helpful description. If you guys do go to the repo, you should be able to see the pull request on your own, if not being able to comment. But this code has errors in it. So what should be the first thing that we try doing? Try and run the code. Very good. So I created some code. There may or may not have been a lot of copy-paste happening. Is exercises microphone code. Git fetch origin. So I download the code to my computer. And it goes into master, which is a mistake. So I go to instruments. Calibrations. So I tell myself I'm going to run this microphone code.py, mic ID. We can run it on the dummy microphone. And we have an error. Oh no. Does anybody see what's missing? Yep, we are missing an equal sign here. One really nice thing about one nice thing VS Code is telling me, or any Python linter, is they can actually find these errors for you. So I fixed it. Run again. Plot force sensor is not defined. something this helpfully points out. We run again. Sensor ID is not defined. Again, it's really helpful that VS Code points this out for me. But this is code that I copy pasted from the plot force sensors code because it worked, except that I renamed certain things. This is a very easy thing to trip yourself up on when you're writing your own code. Because you're like, well, obviously, the code works here. Y-val's phase is not defined. Does anybody see what's happening here? So we define two splines, but we accidentally overwrite. We don't define the new thing that we need. A lot of writing code is going to be like this. Okay, we have a plot up here. We don't have a plot here. Anybody know what the error might be for that? Yes. Exactly. I didn't change the axis that I plot on. And as a process of debugging, again, you run through things again and again. See, these things aren't lining up. A more subtle error that you might see here. What would be an issue with some of this code that some people might point out? It has to do with the equal signs. Yep, PEP 8 violations. Consistent spacing is good. I'm generally a fan of PEP 8. You can use a linter or something to find these sorts of things. Who should fix their code formatting? Sorry, could you speak a little louder? The author. And why would that be? Why should the author fix their code formatting? They should. I mean, objectively, they should be writing good code. We talked about something earlier, though, that if somebody else fixes the code formatting, it's going to change. Sorry? I mean, it's a code change. Exactly. You got it. If I go around and pepate everybody else's code, and somebody runs git blame on the code, it will look like I wrote all the code. Because I was the last person to change the file. And, it's a little frustrating to figure out, like, okay, what happened here? Last commit was change white space. So I tend to be a little aggressive on making people pepate their code, although it depends on where you're working and the culture around it. But yeah, pepate yourself. Don't pepate unto others. So I am making the live changes as I go along. generally, I'll try and make the changes. Partially it depends. If it's a small thing where, oh, this is a small fix, I'll send it in. I've been known to push my own fixes to the code. Especially if it's like, here's one line I've changed out of, 50 lines of new code. If you look at the Git blame logs, you can see like, okay, this was mostly person's X code. Paul just fixed one line of this. But yeah, as we are going around here, we should be adding things like update your code. Start a review, just so you know. I can either add a comment and that will be done. If I click on start a review, it will then GitHub will tell me like, oh, somebody needs to address this comment before everything gets done. So that all the comments about should be microphone ID. You can use Markdown as you edit these, which is kind of nice. We have 2 errors. Should I point them both out? We're using sensor ID in both places. Yes? No? Yes? It's a little questionable. If somebody's making the same error again and again and again, I'll try and say like, replace all instances of sensor ID with microphone ID. That's one comment to deal with rather than getting 10 different comments. Plots. Add repeat comment. But yeah, as I am going around making my small changes, I tend to then add the edits there. So that is doing pull request. Last thing we have time for is going to be issues. So issues are kind of a prelude to a pull request. If I'm working in at my current company, we use Jira. So if there's a code fix we need to make, we will use that. But, if I wanted to fix something, if I said like, hey, something in matplotlib is breaking. Matplotlib is pretty good, but if there was something that I thought matplotlib needed to fix, or if, for example, I had a suggestion of something that needed to be made. As an example, I was reading through this book, Atomic Scala. They have a GitHub page. And I said, hey, here's a couple suggestions I have. You have a little... They had a code example where they were using the circumference of a circle rather than the area. I'm like, hey, this is pretty good, but you should consider adding a chapter on SBT, which is kind of, as I understand, the Scala equivalent of pip, among other things. So, this is a great way to collaborate with other people if you're adding their code, is I just create an issue. So I think anybody should be able to create an issue for this. So if I create an issue, tell me if something's here. Issue, relevant text. Now, this is not a very informative issue. One thing I will point out is that you see that these issues are getting numbered, and our pull requests are getting numbered. So we have pull request number 3. In GitHub, issues and pull requests share the same numbering system. So as you add issues and pull requests, you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a little bit different in GitLab and Bitbucket. But I have issue number 4 here. And if I create a new issue, second issue, I can give a number thing here, and I can either refer to a pull request, or I can refer to another issue. So this is a really good way to be able to, especially when you're creating a pull request, you can say like, hey, we created this issue. We discussed what might be good or bad with something. This is code that's going to fix that issue. Even more, so I'm going to create an issue that says, add some unit tests for force sensor. Let's use the dummy sensor or something. Submit new issue. So we have issue number 5. If I go to a pull request, I have this unit test that I want to create. I can add fixes number 5. And if we go to the issue, request. Sorry, you need to actually do this in the description. Click on this link. And then the issue gets linked here. Even better, we go through, if we approve this pull request, or if this gets merged in, you can actually, depending on how you set up the repo, pull requests might need people to actually formally click a button to approve the pull request. I've generally worked at places where you cannot push directly to master, and all pull requests to master require either 1 or 2 approvals. Have not set this up like that here, but we can say we've merged this in. It automatically closes the issue. So this is a very helpful way that GitHub is able to say like, oh, we brought up this thing that we need to fix. We've created the PR. It says it fixes it. Close the ticket. We don't need to look at it anymore. I like to do it just because I don't like having to scroll through like 50 different branches of, what's the branch that corresponded to my work. So I tend to clean up branches after I'm done with them. So the pull request for that thing will still exist, even though it will be closed. And if I need to say like, okay, somebody merged in these changes, I need to kind of understand the ticket. I'll generally go back to the pull request and I can see what got changed. And you should be able to look at the commits in the pull request, even if the branch itself has been deleted. So that tends to be how I handle things. And of course, on my own personal computer, there's no sense for me keeping extraneous branches that I don't need. A slight bit of history. The other thing that may or may not happen is when you merge your branch back to the master branch, all the commits that came with it get moved over as well. Modulo, I don't think GitHub lets you do this, but in GitLab, there's an option to squash all your commits together. So it just has one commit, which is all the changes from this feature branch become one commit rather than having multiple things. I like to do that just because I don't like digging through really long, complicated commit histories, but that may be more an issue of preference and discussion. We are running a little bit low on time. I'm not going to get into there. I do want to call out this really helpful website called Dang It Git. There's also a stronger language version that you can find. But Git gives you so many ways to shoot yourself in the foot. This website here gives you about 10 or so recipes for, okay, I made this mistake. How do I undo what I've done? So, if you need to undo something, doing a revert. If you've committed code to the wrong branch, I've done that. In fact, I did this here in the tutorial. You can do that with cherry picking. If you need to undo commits, you can use revert. So a very helpful site. I hope it all gives you some benefit somewhere down the line. All right. Well, thank you everybody for coming.